US Physics Olympiad, year 2012. F equal MA. First round. Solutions for all problems you can find below this video in the reference of the description. Problem 1. Consider a dripping faucet where the faucet is 10 centimeters above the sink. The time between drops is such that when one drop hits the sink, one is in the air and another is about to drop. At what height above the sink will the drop in the air be right as the drop hits the sink? Solution. Here we can use a formula height versus time. So this formula looks like this: h equal 1/2 gt square. Let's analyze this. Let's take first drop. First drop take time t to cover 10 centimeters, and second drop take time t over 2. So it means that height must be quadratic to time. It means that the second drop cover height equal this one, which is h over 4. That will be 2.5 centimeters from top. It means that it was on 7.5 centimeters above the sink, which is answer D. Problem number 2. A cannonball is launched with the initial velocity of magnitude v0 over a horizontal surface. At what minimum angle theta minimum above the horizontal should the cannonball be launched so that it rises to a height h, which is larger than the horizontal distance r, that it will travel when it returns to the ground? Solution. Here we can use a well-known formula connecting height and range. Height equal 1/4 of tangent theta multiplied by range. And because h over r equal 1/4 tangent theta, it means that h over r must be greater than 1. It means that tangent theta must be greater than 4, which is for theta equal 76 degrees, which is answer A. Problem number 3. An equilateral triangle is sitting on an inclined plane. Friction is too high for it to slide under any circumstances, but if the plane is sloped enough, it can topple down the hill. What angle incline is necessary for it to start toppling? Solution. Let's check this picture. Here we have inclined plane, and we have equilateral triangle sitting on this plane. Equilateral, it means that all corners are 60 degrees, and then the center of this triangle is the center of gravity for this triangle. And to be this triangle in equilibrium, vertical line from this center of gravity must go to the left from this corner. If it's going to the right from this corner, it will topple down. So it means that critical position is when this line going exactly through this corner. But this angle equal 30 degrees due to symmetry. And from this geometry it means that this angle must be equal 60 degrees for incline. So that's critical angle, and the answer is 60 degrees. US Physics Olympiad, year 2012, F equal MA, first round. Problem 4. The particle at rest explodes into 3 particles of equal mass in the absence of external forces. two particles emerge at a right angle to each other with a equal speed v. What is the speed of the third particle? Solution. Here we can use momentum conservation, which is initially equal 0 and finally must be equal 0. So it means that momentum for two first particles is m multiplied by square root 2v, and it must be equal to momentum of a third particle in opposite direction, which is mv prime. So from here we can find that v prime equal square root 2v, which is answer B. Problem number 5. A 12 kg block moving east at 4 meters per second collides head-on with a 6 kg block that is moving west at 2 meters per second. The two blocks move together after the collision. What is the loss in kinetic energy in this collision? So here we can use energy expression and momentum conservation. Let's count initial energy. Initial energy equal this expression. Now let's count what is total momentum, which is conserved. Initial momentum equal m1 v1 plus m2 v2, which is equal final momentum m1 plus m2 multiplied by common speed v. From here we can find what is this final speed v. Final speed equal this expression, and now we can find what is final energy. Final energy E2 will be this one. Now we can count what is energy loss. This is the expression for energy change. Let's count it. Energy lost will be this expression. And now let's put the numbers. Here we need to emphasize that V2 is negative. This is why we put here a plus. And the answer is 72 joules, which is answer D. Problems number 6 and 7. The following information applies to questions 6 and 7. Two cannons are arranged vertically with the lower cannon pointing upward towards the upper cannon and the upper cannon pointing downward towards the lower cannon, 200 meters above the lower cannon. Simultaneously they both fire. The muzzle velocity of the lower cannon is 25 meters per second and the muzzle velocity of the upper cannon is 55 meters per second. Question number 6. How long after the cannons fire do the projectiles collide? And question 7. How far beneath the top cannon do the projectiles collide? Solution. First of all, we can use here a proper frame of reference. You could take a frame of reference which is moving with acceleration g downward. In this frame, the velocities of these both cannon cores are constant, and we can find what is a relative velocity. That will be 25 plus 55 meters per second, which is 80 meters per second. And to find what is total time, we need to divide full distance by this relative velocity. That will be 200 over 80, which is 2.5 seconds. That's answer B, correct one. Next question is number 7. how far beneath the top cannon do the projectiles collide? Solution. So, using this equation for total height, we can count it after putting numbers. That will be around 170 meters, which is answer E. Problem number 8. A block of mass m equal 3 kg is moving on a horizontal surface towards a massless spring with the spring constant K equal 80 Newton per meter. The coefficient of kinetic friction between the block and the surface is mu K equal 0.5. The block has a speed of v equal 2 meters per second when it first comes in contact with the spring. How far will the spring be compressed? Solution. Here we can use work energy theorem. It means that initial energy, which is completely kinetic energy for this mass, turning to potential energy of the spring plus work done by force of friction. Let's write this expression. This is the formula. 1/2 mv square, that's kinetic energy for mass, mu k mgx, that's work done by force of friction, and 1/2 kx square, that's final potential energy for compressed spring. As we can see, this is a quadratic equation to x. Let's put the numbers and count the result. This is our equation in numbers, and after simplification we have this equation. Let's try the solution. This is the solution for two roots, but we have to take a positive root, not negative. And for positive we have 0.24 meters, which is answer B. Problem number 9. A uniform spherical planet has radius r and the acceleration due to gravity at its surface is g. What is the escape velocity of a particle from the planet's surface? Solution. Escape velocity in some particular point means that total energy of this satellite is 0. Let's write this expression for total energy. Right on the surface of this planet we have total energy equal kinetic energy plus potential energy, which is negative g m m over r, where r is radius of this planet. Let's express this through g. We can replace this expression for potential energy by this formula, and here g multiplied by mass of planet and divided by r square, that will be acceleration due to gravity on this surface of this planet. So that's equal mgr. And when we put this to this equation, we can find what is the escape velocity. Escape velocity equal square root from 2gr. That's answer C, correct one. Problem number 10. 4 objects are placed at rest at the top of an inclined plane and allowed to roll without slipping to the bottom in the absence of rolling resistance and air resistance. Object A is a solid brass ball of diameter d. Object B is a solid brass ball of diameter 2d. Object C is a hollow brass sphere of diameter d. Object D is a solid aluminium ball of diameter d. Aluminium is less dense than brass. The balls are placed so that their centers of mass all travel the same distance. In each case, the time of motion t is measured. Which of the following statements is correct? Solution. Here we need to take into account what is the expression for moment of inertia for each object. Moment of inertia for any round object we can express in form of I equal beta mr square, where beta could be some kind of coefficient. For a hollow sphere, beta equal 2/3. For solid sphere, that's equal to 2/5. And the result depends only on this beta. If we have beta greater, we have greater time, because for more beta we have more energy going to rotational motion and less energy going to translational motion. It means that linear acceleration for such objects will be less. It means that the result is the same for objects A, B and D, and for object C time will be greater. So that's the answer. US Physics Olympiad, year 2012, F equal MA. First round. Problem 11. Solution for this problem you can find below this video in the reference of the description. As shown below, Lily is using the rope through a fixed pulley to move a box with a constant speed v. The kinetic friction coefficient between the box and the ground is μ less than 1. Assume that the fixed pulley is massless and there is no friction between the rope and the fixed pulley. Then, while the box is moving, which of the following statements is correct? Solution. Let's do first quality analysis. Suppose that initially angle between rope and the horizon is very small. In that case, force of tension approximately equal to mu mg. And mu is less than 1, it means that it's mostly like less than mg. And now suppose that angle is almost 90 degrees. In that case, magnitude on the rope almost mg. So it means that it's greater than mu mg. And the statement A is not correct. Let's check statement B. The magnitude of the friction between the ground and the box is decreasing. This could be true because during the motion angle is increasing and tension helps to reduce normal force, and this will reduce force of friction. So that's very close to a right answer. Answer C. The magnitude of the normal force on the ground on the box is increasing. This is obviously not true, because initially this magnitude equal almost mg, and finally it's almost 0. D. The pressure of the box on the ground is increasing. That's the same as statement C, so that's not true. Statement E. The pressure of the box on the ground is constant. That's again not true, because we just proved that initially it was mg and finally it was almost 0. Now let's prove our answer B by formulas. Suppose that the angle between a rope and the horizontal is theta, force of tension is T, force of friction is F, and normal force is N. Now let's write equations. So first we have tension multiplied by cosine theta equal force of friction, horizontal part. So for vertical part we have tension multiplied by sine theta plus normal force equal mg. And also we have a relation between force of friction and normal force. Force of friction equal mu multiplied by normal force. Now let's solve this system. First we can express normal force from second equation. We have this expression. Now we put this normal force in this expression for force of friction. And we can put this force of friction in the first equation. So this is the equation for tension. So we found that tension equals this expression. Now let's count what is normal force. Normal force is this one. And finally we can count what is force of friction. Force of friction, this one. Let's investigate behavior for all three forces. Tension, normal force and force of friction. If we look at this formula, we can say that when angle is close to zero and increasing, tangent increasing, it means that force of friction always decreasing. For the same reason, normal force always decreasing. And the tension, if we investigate this function has a maximum between 0 and 90 degrees. So initially it's increasing and after that it's decreasing. So it means that tension initially decreasing and after increasing. So that's the behavior for tension. And now let's see what happened here. A. The magnitude of the force on the rope is constant, which is not true, it's not constant. B. The magnitude of the friction between ground and the box is decreasing. Yes, that's true, we just investigated. And C, D and E, they are not correct because of this formula. Normal force always decreasing, which is not clear for C, D and E. So correct answer is B. US Physics Olympiad, year 2012, F equal MA, first round. Problem number 12. Solution for this problem you can find below this video in the reference of the description. A rigid hoop can rotate about the center. Two massless strings are attached to the hoop, one at A, the other at B. These strings are tied together at the center on the hoop at O, and the weight G is suspended from that point. The strings have a fixed length regardless of the tension, and the weight G is only supported by the strings. Originally OA is horizontal. Now the outer hoop will start to slowly rotate 90 degrees clockwise until OA will become vertical, while keeping the angle between the strings constant and keeping the object static. Which of the following statements about the tensions T1 and T2 in the two strings is correct? Solution. Let's redraw this picture with a mention of angles. Let's theta1 will be angle between first string and the vertical, and theta2 is the angle between second string and the vertical. Both are positive. And let's write the equations for static equilibrium in any position for these angles. In horizontal direction we have this equation T1 sine theta 1 equal T2 sine theta 2, and in vertical direction we have this equation T1 cosine theta 1 plus T2 cosine theta 2 equal G. Solution for these two equations are this one for T1 and this one for T2. Let's investigate them. We have in the denominator sine theta 1 plus theta 2, and this is constant, and this sign is also positive because it's lie between pi over 2 and pi. And let's check what happens if the angles are changing. T1 start from sine theta 2. Initially it's increasing, and after reaching theta 2 pi over 2 it starts to decrease. And for T2 we have initially sine theta 1 is 1, so it means that T2 has a maximum, and finally it's reducing till 0 in position when theta 1 is 0. So that's the behavior for T1 and T2. And let's check what happened to these answers. Answer A. T1 always decreasing, which is not correct. We investigated because initially it's increasing and after that it's decreasing. T1 always increasing, that's not correct too. T2 always increasing, which is not correct, it's always decreasing. And T2 will become 0 at the end of the rotation. That's true. In the end of rotation sine theta 1 equals 0 and T2 equals 0. And answer E, T2 first increase then decrease, which is not true, it's always decreasing. So correct answer is D. Also I can mention that this answer we could guess, because in position when theta 1 is 0, the equilibrium will be when tension T1 is G and tension for T2 is 0. It's just a loose position. So this is why we can guess this answer. Problem number 13. Shown below is a graph of the x component of force versus position for a mass equal 4 kg cart constrained to move in one dimension on the x-axis. At x equals 0, the cart has a velocity of negative 3 meters per second in the negative direction. Which of the following is closest to the maximum speed of the cart? Solution. Because on this graph we have force depending on displacement, we can use energy approach here, because cart getting energy which is equal to area under the curve, and we see that positive area is till 0.6 meters, and after it's negative. It means that cart will get maximum velocity in point C, and we just need to count what is the area of this figure, this rectangle and this triangle. Let's count it. For rectangle we have 5 newtons multiplied by 1 meter, which is 5 joules, and for triangle we have 5 multiplied by 5 and divided by 2, which is 12.5. So total area will be 17.5 joules. and we need to count initial energy, which corresponding to speed 3 meters per second. So total kinetic energy equal initial kinetic energy plus work done by this force. We can mention that it doesn't matter that our body move in opposite direction initially, because it will return with the same speed in a positive direction in the same point. So, and total answer will be 35.5 joules total kinetic energy. And now we can find what is the speed in 0.6 meters. So total kinetic energy equal 35.5 joules. From here we can find what is V square. That will be 17.75. And finally speed will be 4.2 meters per second, which is answer E. US Physics Olympiad, year 2012. F equal MA. First round. Problem 14. Solution for this problem you can find below this video on the reference of the description. A uniform cylinder of radius A originally has a weight of 18 newtons. Half 10 of Fx cylinder hole at 2/5A was drilled through it. It weighs 65 newtons. The axes of the two cylinders are parallel and their centers are at the same height. A force T is applied to the top of the cylinder horizontally. In order to keep the cylinder at rest, the magnitude of the force is closest to solution. In this problem, we assume that the center of cylinder is fixed. In other case, if it's not fixed, it will roll to the right. And suppose that this center is fixed. Now we can drill the hole symmetrical to original one to the left, same distance, 2/5A, and take it off. In that case, the left part will be in equilibrium, but drilled one create torque around the center of gravity, which is equal 15 newtons multiplied by distance 2/5A, and it must be equalized by torque created by force F, which is F multiplied by A. So here we have equation. Torque F multiplied by A must be equalized by force of gravity 15 newtons multiplied by 2/5A. So from here we can find that force F equal 6 newtons. Problem number 15. A car of mass M has an engine that provides a constant power output P. Assuming no friction, what is the maximum constant speed V maximum that this car can drive up a long incline that makes an angle theta with the horizontal? Solution. In this problem, we assume that there are no kinetic friction, because without friction, car cannot just drive up the hill. So here we have static friction. And let's write equation for power. Solution. We know that power equal force created by engine multiplied by speed. In our case, because the car is going with a constant velocity, it means that force created by engine must be equalized by part of force of gravity in opposite direction. So it means that we have equation power equal mg multiplied by sine theta multiplied by speed v. So from here we can find what is speed v. That will be p over mg sine theta, which is answer A. Problem number 16. Inside a cart that is accelerating horizontally at acceleration A, there is a block of mass m connected to two light springs of force constants K1 and K2. The block can move without friction horizontally. Find the vibrational frequency of the block. Solution. Here the acceleration has no influence on friction. It has only influence on point of equilibrium for compressed or stretched springs, and after that it will vibrate as without acceleration. Now if we compress one spring and stretch other spring with the same distance x, there will be force acting in opposite direction, which is proportional to K1 plus K2. This frame of reference, which is moving with acceleration A, the equation for motion of this block will look like this. Mass multiplied by acceleration in direction x is equal negative K1 plus K2 multiplied by displacement x. So we can rewrite this equation in form of this one, and this form corresponds exactly to the form of harmonic oscillation. We know that the angular frequency for this motion we can get from this coefficient, that will be omega square. It means that the frequency equal this one, which is answer E. US Physics Olympiad, year 2012. F equal MA, first round. Problem number 17. Shown below is a log by log plot for the data collected of amplitude and the period of oscillation for certain nonlinear oscillator. According to the data, the relationship between period t and amplitude A is best given by such equations. Solution. If we look at this graph, log by log, we can write equation which is corresponding to this graph. Slope for this graph is 2, and for log A equal 0, log t equal 3. So it means that this equation must look like this. Log t equal 3 plus 2 times log A. Now let's put 10 in power of both of these expressions. So we have t equal 1000 A square, which is answer A. Problem number 18. A mass hangs from the ceiling of a box by an idle spring. With the box held fixed, the mass is given an initial velocity and oscillates with a purely vertical motion. When the mass reaches the lowest point of its motion, the box is released and allowed to fall. To an observer inside the box, which of the following quantities does not change when the box is released? Ignore higher resistance. Solution. The only difference between box in first case and box in second case when it has a free fall, at point of equilibrium has a different position. In the second case, when box is released, when mass in lowest point, the point of equilibrium moves up. It means that amplitude is increasing. And because we have ideal spring, the period must be the same. Let's check the answers. The amplitude of the oscillation. That's not true. Amplitude will increase. The period of the oscillation. That's true. Period will be the same. C. The maximum speed reached by the mass. Maximum speed will increase because amplitude will increase. D. The height at which the mass reached its maximum speed. Yes, that's true, because maximum speed will be in position of equilibrium, and the position of equilibrium will change. The maximum height reached by the mass. This position will change because amplitude will change. So, correct answer is B. Problem number 19. A 1500 watt motor is used to pump water a vertical height of 2 meters out of a flooded basement through a cylindrical pipe. The water is ejected through the end of the pipe at the speed of 2.5 meters per second. Ignore friction and assuming that all of the energy of the motor goes to the water, which of the following is closest to the radius of the pipe. The density of water is ρ equal 1000 kilograms per cubic meter. Solution. We can count power by regular formula. Power equal force multiplied by speed. In our case, force equal force of gravity, and this is how a column of 2 meters high move up with a speed v equal 2.5 meters per second. So we need to multiply weight of this column by speed. That will be power. Pi r square h, that's a total volume of this column of water, multiplied by rho, that's a total mass of this column, multiplied by g, that's a weight, or that's a force which produce this motor, and the force multiplied by speed, that's a power. And from here we can find what is r square. R square equal power over v pi rho g h. When we put numbers, we have this expression, which is equal approximately 0.01. So to find what is r, we need to get a square root from this, and that will be r equal 0.1 meters or 10 centimeters, which is answer D. US Physics Olympiad, year 2012, F equal MA, first round. Problem 20. Solution for this problem you can find below this video on the description reference. A container of water is sitting on a scale. Originally, the scale reads M1 equal 45 kg. A block of wood is suspended from a second scale. Originally, the scale reads M2 equal 12 kg. The density of wood is 0.6 gram per square centimeter. The density of the water is 1 gram per square centimeter. The block of wood is lowered into the water until half of the block is beneath the scale. what is the resulting reading of the scales. Solution. In this problem we just need to count what is the buoyancy force acting on this block from water. First, because we know what is the mass of this wooden block, and we know what is the density of this wood, we can count what is the total volume of this block. After that we can count what is the half of this volume, and after that we can count what is the buoyancy force from water exerted in the second case, because we know what is the density of water. Let's do this. Volume of this wooden block equal mass of this block divided by density of wood. Next, half of this volume equal this expression. And next, buoyancy force or buoyancy mass equal this expression. After putting numbers, we will get 10 kilograms. That's a buoyancy force which is acting on the wooden block from one side and acting on a lower scale on the second case. So it means that we have to subtract 10 kilogram from the second reading and add 10 kilogram to the first reading. That will be 55 kilogram for M1 and 2 kilogram for M2. Problem number 21. A spring system is set up as follows. A platform with a weight of 10 newtons is on the top of two strings, each with a spring constant 75 newton per meter. On top of the platform is a third spring with a spring constant 75 newtons per meter. If a ball with a weight of 5 newtons is then fastened to the top of the third spring and then slowly lowered, by how much does the height of the spring system change? In this problem we just need to count what is the spring constants for parallel connected springs and series connected springs. Two lower springs are connected in parallel. It means that equivalent K1 equal 2K. Also, next we have upper springs connected to these lower springs, so and they are connected in series. It means that total K could be counted like this, and K2 equal 2/3 K. And the last step is to find what is displacement. That will be force 5 newtons divided by equivalent K for whole system. And the answer is 0.1 meters or 10 centimeters. And answer is 0.1 meter, which is C, correct answer. Problem number 22. The softest audible sound has an intensity of I0 equal 10 power negative 12 watt per meter square. In terms of the fundamental units of kilograms, meters and seconds, this is equivalent to which one? We have 5 choices. Solution. To find the units in SI system for this intensity, we need to convert watts to this fundamental units. Let's count power. Power equal joule per second, joule equal newton by meter, and newton equal kilogram by meter per second square. Finally, that's equal kilogram by meter square over second power 3. And finally, I0 equal 10 power negative 12 kilogram per seconds cube. That's answer A. American Physics Olympiad, year 2012, F equal MA. First round. Problem 23. Which of the following sets of equipment cannot be used to measure the local value of the acceleration due to gravity, g? There are 5 different sets. Solution. Let's examine all these sets. A spring scale which reads in force units and known mass. This set could be definitely used because if we divide weight by mass, we will get g. So it means that this is not correct answer. B. A rod of known length and unknown mass and a stopwatch. This equipment could be used if we take this mass and use it as a pendulum with a known length. We can count what is g using period and using length formula. So this is not correct answer. C. An inclined plane of known inclination, several cards of different known masses and a stopwatch. Here we definitely need to know what is the height from where these cards can be pushed, or the distance they travel, but we don't have measure for that, so this is definitely cannot be used to measure what is g, so it means that this is correct answer. D. A launcher which launches projectiles at a known speed, a projectile of known mass and a meter stick. This could be used for g because we have formula to find what is maximum range if we know what is initial speed. So for angle 45 degrees we can get the maximum range, but here we can repeat our measurements for different angles and find what is the maximum range and find what is the g using this known formula. So it means that this is not correct answer. And last one, E. A motor with a known output power, a known mass, a piece of string of unknown length and a stopwatch. This one is tricky because we have a motor with a known output power, and we can hang this motor using string and turn it on and count what is the total time for this motor to pull this up the string. It means that we know what is power, we know what is total time, so we can get total energy multiplying power by time, and this energy equal mgh. So mass is known, it means that we can find what is gh. And the second thing we can use this motor as a pendulum, and we can measure what is a period of oscillation for this pendulum, and from this period we can find what is g over L. So it means that from first experiment we can find what is g multiplied by L, and from the second experiment what is g divided by L. From here we can find what is g and also what is L. So it means that E is not correct answer, and we have only one correct answer, is C. Problem 24. 3-point masses M are attached together by identical springs. When placed at rest on a horizontal surface, the masses form a triangle with the side length L. When the assembly is rotated about its center at the angular velocity omega, the masses form a triangle with a side length 2L. What is the spring constant K of the springs? Solution. First, let's draw the picture of this triangle. When this construction rotates with the angular speed omega, the length of this side B equal 2L. Also, we need to count what is the length of this side A connecting any mass with the center of triangle. This A from the geometry equal L over cosine pi over 6 or 30 degrees. Now let's write the equation for centripetal force which acting on each rotating mass. Because all springs enlarged by distance L, the force of tension in each spring equal KL. And this force directing in this direction, and for each mass we have total force composed from two forces, and we need to count what is the projection of these two forces on direction of this A part, which is 2KL multiplied by cosine 30 degrees or pi over 6. And from other hand, this force must be equal to centripetal force, which is MA omega square. And A we already counted. So when we put this in this expression, we can cancel L, and finally we can count what is K. K equal M omega square over 2 cosine pi over 6 square, which is 2 over 3 M omega square. That's answer C, correct one. Problem number 25. Consider the two orbits around the Sun shown below. Orbit P is circular with radius r. Orbit Q is elliptical such that the furthest point B is between 2r and 3r. And the nearest point A is between r over 3 and r over 2. Consider the magnitudes of the velocities of the circular orbit VC, the velocity of the comet in the elliptical orbit at the furthest point VB, and the velocity of the comet in the elliptical orbit at the nearest point VA. Which of the following rankings is correct? Solution. From these 5 equations we can guess the result and check result C. If we compare 10 VB with VA, we can say that the furthest difference could be when distance from A to Sun is r over 3 and furthest is 3r. It means that the biggest difference between these two distances is 9 times. It means that due to angular momentum conservation, VA multiplied by 9 must be greater than B, and we have 10 VB greater than VA. So this is a correct one. And now let's check VA greater than VC. If in this point we have a circular orbit on a small distance, we have this speed VA must be greater than VC, but this orbit is not circular, it's elliptical. It means that this speed must be greater than for circular orbit. It means that in any case VA must be greater than VC. So C is the correct answer. It means that we even don't need to check answer A, B, D, and E.